AP Calculus, Unit 1, Day 1, 2. We are at Part 6. This is just to finish up a couple components that we weren't able to get to with the other notes. I think I skipped over them, so I apologize for that. I'll make a note in Google Classroom, so hopefully you see that before you get panicky. If there's ever anything that we ever miss, we will eventually get back to it. Okay, so here we were talking about these first two examples. We were looking at limits that do not exist, so we can help define what the definition of a limit is. Okay, so as I'm looking here, it says find each of the following. So I'm trying to find the limit as f of x. The limit of fx as x approaches 2 from the left. So here's my positive 2 right here. So I'm approaching it just from the left. So obviously as I come up with the function, the y value, which again is what f of x is, the y value is equal to 3. Okay, so now I'm looking at limit of fx as x approaches 2 from the positive direction, which is going to be from the right. So as I come down the function, now I'm not going to go all the way to 2, but I'm going to go all the way up to and almost to 2. So this looks like it's approaching negative 3. And on the last part, we're just going to say, hey, what's f of 2? Well, f of 2 was defined at 3. So now they ask, does the limit of the function exist or not? Why or why not? And what we see here is since the limit of the function as x approaches 2 from the left does not equal the limit as f of x approaches 2 from the right, therefore the two-sided limit, the limit of f of x as x approaches 2, does not exist. Okay, and if I just erase these really quick, this obviously is known as a jump discontinuity. Okay, so with these three examples, we see a jump discontinuity, a hole, and a vertical asymptote. Okay, so those are 3 times where limits do not exist. Okay, and the last part here, I think this is on page 8 of your note packet. That last thing was on page 4. I'm throwing this out there here. You don't need to take notes now. So I want you to see this, and I'm going to try to draw a few things to it. So we see this f prime of x, we don't know what that is. This is known as the difference quotient. Okay, and we're bringing this word derivative, that's unit 2. But we see, hey, the limit of f of x plus delta x minus f of x all over delta x as delta x approaches 0. We see this picture. What the heck does that mean? And then also there's this example. It's a little bit easier because it's f of x plus h minus f of x all over h as h approaches 0. But in both cases, we see delta x is approaching 0 and h is approaching 0. So I'm trying to find when the denominator is approaching 0. So I also want us to go back to what do we know about slope? So we have the slope formula. Again, change in y over change in x is equal to y2 minus y1 over x2 minus x1. So what does that mean? Well, I'm going to, in red here, draw in using the terminology down here. So if I have some point x, and so this point P is actually at x, comma f of x, and this point Q is at x, and let's say I'm going to use the easier term down here, so delta x, use h. So if I go over to from x, go over h units. So then therefore this point is x coordinate x plus h, and then y coordinate f of x plus h. Well, if I just did the slope formula, okay, and took the difference quotient, change in y. What's my y's? My first y, blue here, f of x plus h, minus the other y coordinate, f of x, that's y2 minus y1, and then what's my x2? x plus h, and I subtract x1, which is x, x plus h minus x is just h. Okay, so this is really just based off of the slope formula. Again, don't write this down. Hopefully you did write it down, and just try to visualize it. We're going to come back to this later on. But I know it was sitting there and I didn't want you to panic about that. All right, and that's day 1, 2 notes.